Okay, so today we're going to start discussing matrices. So matrices, they are an array of elements organized in rows and columns. They can be numbers, they can be variables, they can be expressions. So if we look at this first, I'm going to say matrix A right here. I have rows, I have 2 rows, and I have 3 columns. And so this dimension of this matrix would be a 2 by 3 matrix. So I always talk about it in terms of the rows by the columns. So then if I want to talk about a row matrix, I would think about, and I could put anything in here, but I would think about a row matrix. Let's say 1, 2, 3, 4. If I talk about a column matrix, let's say I would say ABC, and would be a column matrix. If I talk about a square matrix, I could have a 2 by 2, I could have a 3 by 3. Let me do a 3 by 3. And that means I would have 3 rows and 3 columns. So let's say 1, 2, 3. I'll just do 4, 5, 6, 7, 8, 9. So if you look at this, I have here 3 rows and I have 3 columns. Now, if I look at example B, I want to know the dimensions. So I look at my rows. I have 3 rows, and then I look at my columns. I have 2 columns. So this is a 3 by 2. Then it also asks what number is in row 2, column 1. So row 2 is going to be right here. Column 1, this is going to be 6. Then it asks what number is in row 3, column 2. So row 3, column 2 would be 7. So we would start out, this would be row 1, row 2, row 3, column 1, column 2. Okay, now matrices are going to be equal if they are the same size and if they have the same elements, or if the same elements can be simplified to be the same. So if I look at example 1, matrix A, this is going to be a 2 by 3. This is also a 2 by 3, so the same size, they're the same size. Now I have 6 divided by 3 is 2, that's great. 4, 4, I have a -1. -3 divided by 3 is -1, that looks good. Then I have 3, 1, 0, that looks great, so A equals B. If I look at example 2, this is going to be a 2 by 3. This is going to be a 2 by 4. So they are not the same size. So A does not equal B in example 2. Now, if I want to go ahead and solve for variables, what I would do is I would go ahead simply and I would set the corresponding elements equal to each other. So in this case, I could go ahead and set x equal to 7. This is very simple. We're going to have ones where we actually have to solve. And then here, I could go ahead and do -1 equals y. So that was a super simple one. So for instance, this next one, I would do y equals 3x minus 2. 3 equals 2y plus x. Now it looks like I have 2 equations and 2 variables. This one looks like it's set up very nicely for substitution. So let's go ahead and substitute in y. So 2 times 3x minus 2 plus an x. So I'm substituting this in for y. So I have 3 equals 6x minus 4 plus x. I can move this over to this side. 7 equals 7x, x equals 1. So I have my x is 1. My y would be y equals 3 minus 2, which is 1. So I have my ordered pair of 1, 1. I could do the same type of thing for this next one. What I would have to do here is my x, 3x plus 1 equals x minus 1. All right, these are like, so I could go ahead and subtract 2x equals negative 2. X equals negative 1. Then I could go ahead and set 2y minus 1 equals 3y. So let's say I move this over here, negative 1 equals y. And then for my last one, I have here 3z minus 2 equals 5z minus 4. So let's move this over here. So I have negative 2z equals, I'm going to subtract, or I'm going to add actually negative 2z equals 1. So it looks like I have negative 1, and 1. I know I'm going through these kind of quickly, but feel free to pause the video and then you can review it if you need to. Now we can go ahead, we can add and subtract matrices. We just have to make sure that we add and subtract corresponding entries and the resulting matrix is going to be the same size. So for this one, I'm going to subtract. So I would do negative 1 minus 5, 3 minus 0, 4 minus 1, 2 minus 3. My resulting matrix is going to be negative 6, 3, 3, negative 1. Now here, I can't actually add these because they're not the same size. So I'm just going to say can't add different dimensions. All right, the last thing we're going to talk about before we put everything together is we can also multiply by a scalar. So what I mean is I can multiply by a constant or a constant expression. So this, I would multiply every element. So I have 2 times 2 is 4, 2 times 1 is 2, 2 times 6 is 12, 2 times 0 is 0. Now I can put everything together, and this is using order of operations. So here I'm going to go ahead and I'm going to multiply first. So I have 2x, 6, 2, 6y. And then I would go ahead and I would add it. So now what happens is I would add my corresponding terms. So 2x plus 4. I went ahead and added those. Then I would add 6 and 1 is 7. Negative 1. And then 6y plus 5. But now what I have to do is I have to solve for x and y. So I would have here 2x plus 4 equals 10, 2x equals 6, x equals 3. I would do the same thing over here, 6y plus 5 equals 11. Oops. 6y equals 6, y equals 1. Okay, so if there is anything that you didn't understand, feel free to go ahead and pause this, review it, go ahead, rewind, and watch it over again. But that is our introduction to matrices. Have a great day.